So in this clip we'll talk about the co-determination of the interest rate and the exchange rate. So the interest rate being determined in the money market and the exchange rate being determined in the foreign exchange market, and we'll consider how these two interact. Let's jump right into it and very briefly review both of these markets. So the money market is usually shown in interest rate real money balance space. The real money supply, M over PS, is exogenously determined by the monetary authorities, the central bank, and real money demand is a downward sloping function of the interest rate and a positive function of income. That is what determines intersection here, where money supply, real money supply and real money demand are equal. We get our equilibrium interest rate. So that is interest rate determination. And second, based on the idea of arbitrage, we have a model that gives us today's level of the exchange rate and dollar returns on two different deposits. One of them, our dollar, is just the domestic interest rate, the domestic return on financial investment, and the other is the euro rate plus E hat E, the expected exchange rate. So where these are equal, our dollar, the interest rate in the US, is equal to the interest rate in Europe plus expected exchange rate depreciation, and that is our no arbitrage condition, and it determines the equilibrium exchange rate. Let's just recall here real brief what E hat E is. That is the expected exchange rate for one period out minus today's exchange rate divided by today's exchange rate. So this is the growth rate of the expected growth rate of the exchange rate, where E is defined as the dollar price of €1, so that a higher value of the exchange rate implies a more depreciated dollar. So just to keep this in mind, so this graph on the right here is what gives us exchange rate determination. Now we want to put these two together. Now how do we do that? Well, we see it's easy to see here that this axis and this axis are the same. We have here the interest rate, and here we have the dollar interest rate, so that we can in fact put this, the left hand graph, on the bottom of the right hand graph by turning it 90 degrees towards the right. Let me go to a new page and show you how we'll do that. So exchange rate here, the dollar return rates on this axis, the interest rate, and then in this direction real money balances. So that is the money market diagram turned clockwise. Here we have real money supply and real money demand as the downward sloping function of the interest rate. So you see that at this point we get the domestic interest rate our dollar, which then enters the upper part of the diagram as the rate of return on financial investment in the US, and we add to that the arbitrage condition that the sum of the euro interest rate plus the expected depreciation must be equal to the dollar interest rate for the foreign exchange market to be in equilibrium, and we get our E star. So in that sense, we get here interest determination and then exchange rate determination jointly. Now, how do we think about policy in this diagram? Well, let's consider one case where the national monetary authorities, the central bank in the US, say, wants to decrease the interest rate. What is the impact on the domestic financial markets, and what is the impact on foreign exchange markets? So first, we get that decrease in the interest rate with an increase in the money supply. Let's call that M over PS2. We see that we get a new equilibrium here and a new interest rate, a lower interest rate that clears the domestic financial markets. What has happened in the process? Well, the central bank bought bonds. By doing so, provided the private sector participants with cash, and by buying the bonds, increased their price, which reduced the yield on the bonds so that the interest rates fall. That is this move towards the left. That translates then to the upper part of the diagram, and we see that we get a new intersection here with a new E star that is higher than the initial one, so that we have a lower R and a higher E, which means, of course, more depreciated, since a higher E means the dollar price of €1 has gone up. More dollars need to be paid for every euro. So what has happened in the upper part of the diagram here? How do we get to the new equilibrium? Well, if we are initially at this equilibrium that I just circled red here, then the decrease in the interest rate implies a violation of the arbitrage condition. So the dollar interest rate is lower than the euro interest rate plus the expected depreciation, which means that holders of financial investments in the US will rush towards Europe, buy euros, and invest in financial assets there in order to get the higher rate of return. And by doing so, by buying euros for dollars, reduce the price of dollars and increase the price of euros. So if this happens, the rise in the exchange rate, and that ultimately leads to the new equilibrium where the dollar rate, the new dollar rate, is equal to the sum of the expected depreciation and the euro rate. Now, let's recall as well what that really means for the expected depreciation. The important thing here is that the expected exchange rate one period hence, here the yellow highlighted expected level of the exchange exchange rate one period hence has not changed, so that value against the now higher, more depreciated exchange rate today leads to a lower depreciation in the future. So the sum of now lower depreciation in the future and the unchanged euro interest rate will now again be equal to the lower dollar rate. And just like that, the domestic financial market and the foreign exchange market interact to determine interest rates and exchange rates.